Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about the need of multi-threading models, what are its types and the advantages of disadvantages of each type of these multi-threading models. Support for threads may be provided at each level of the computer system. For example, the user-level threads can be supported by the users and the kernel-level threads can be supported by the kernel. The user-level threads are always above the kernel level and are supported without the help of the kernel. And the kernel-level thread is directly managed by the operating system. Now, virtually all the types of the operating system, including the Windows family, Linux, Micro and Mac OS X and the kernel systems of Unix too, use this multi-threading environment. Now, the kernel, user and the operating system architecture must exist a relationship between them. So today we will discuss about all the three types of models that can be implementing this relationship. The first one is the many-to-one model. In a many-to-one model, there are many user-level threads mapping to the user-only kernel-level thread. Now, as thread management is done by the thread library at user space, it is more efficient. However, and the entire system will get blocked if only a single thread is making a blocking system call. And also, all the user threads cannot run concurrently as only one kernel thread can be executed with one user thread at a time. So the other user threads must wait for the user threads to be mapped with the kernel. Green thread, which is a thread library provided by Solaris 10 and the older version of the Solaris 10 with the Linux family too, use this one-to-one model implementing their operating system. The early versions of Java also use these green threads. Now, as there are discrepancies of not using the threads concurrently and other challenges, this many-to-one model is not implemented nowadays. Now, the next model is a one-to-one model. In one-to-one model, a single user thread is mapped to a single kernel thread. Here, all the user can run concurrently with the help of each kernel corresponding to them. And also, a kernel can call any other thread if a thread calls a non-blocking and blocking system call. Now, the system will not get blocked at all. The only drawback in this one-to-one system or model is that using and creating the user thread will also cost the using and creating a separate and corresponding kernel thread too. So the overhead of this kernel thread creation can be a burden on the system's improvement, better performance. Now this performance can be done with the help of restricting the number of kernel threads supported by a system. Now, many models and many operating systems implements this one-to-one model, but because of the drawbacks, many users restricting it too. The Linux along with the Windows families use this one-to-one model. The third part is a many-to-many model. In a many-to-many model, it multiplexes the many user-level threads to be mapped with equal or lesser number of kernel-level threads. Now, these kernel-level threads can be implemented directly via for an application or depending on a machine. An application may be allocated more kernel-level threads on a multiprocessor rather than a single processor. Let's consider the effect of concurrency on these systems. Where a many-to-one model, the many user-level threads cannot run concurrently as one kernel-level thread can execute a user-level per at a time. And in one-to-one model, this can be done because a user-level thread is supported by its corresponding kernel-level thread. But the incurring overhead of the creation of kernel-level thread is there. So many-to-many model suffers none of these efficiencies. Now these discrepancies can be done with the help of this many-to-many model. In many-to-many model, many user level threads can be created by a user where it can be supported by the kernel differently on this multiple processors. Now the multiple processor, and in each core this each kernel can be executed, and also it can run concurrently, so the concurrency problem is also solved. If a thread is making a block system call, then other threads in the user spaces can perform the kernel level threads to execute the actual function. Now, one variation of the many-to-many model that it includes the many user level threads can be mapped to equal or lesser number of the kernel threads, along with each user level thread can be corresponded to each kernel level thread. This level or this model is known as a two-level model. This two-level model is often implemented in many operating systems, as it can be performed the advantages of both the one-to-one model and many-to-many model. Nowadays, the Solaris 10 and the other advanced version of the Solaris include this many-to-many two-level models, and previously it used the one-to-one model. So in this three-way, the models can help in build the relationship between the user level thread and the kernel level thread, and in between the user level and kernel level thread. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.